This is Nathan Cruz with Carlson Software, and in this video I'm going to show you some uh, more advanced and detailed methodologies that we have in our point cloud Bareground filtering feature. So first thing I'm going to do is make sure that my projection, by clicking on the scenario, that my projection is set to my desired workspace area. This is important if you want aerial images and point clouds and surfaces points to actually line up when you bring this stuff in. I've already selected this particular point cloud from PixElement, and I'm going to apply a point thinning factor of 16, so I get around 1,000,000 points or so. And in this case, the projection isn't burned into the LAS file, so I do need to select it manually. The default is use the projection in the file, but in this case, we have to choose it. And in this case, it's going to be an 8083 Michigan South in meters. That's the way it was produced. So I'm going to go ahead and load the point cloud. And I'm also going to load an ortho image from this project. I'll make sure that I pick this one. PixElement does a really nice job of stitching all those small photos together. Same Michigan South. I'm not going to drape it to the surface because I'm going to use this as a reference while I'm trying to clean up the surface. So what I'm going to do is make it a bit transparent, and I'm going to change the elevation down to about 845. So you can sort of see it's just below the point cloud, but it's fairly close to it. And the reason for that is you can see that there's some point cloud that we have this conveyor machine, and you can actually see the points floating above in there. And then if we go and look over in this area, we can see we have a truck. And so basically we're just using the photo as a reference because you can see the extra cloud points up here, and we want to get rid of these so we have clean bare ground. And again, same in this case. So we're just using this ortho image at this point just as a sort of helper. So what I'm going to do is I'm going to select the point cloud in my Scene Explorer just by clicking on it. I'm going to start the filter command up in the object commands. And what I'm going to do is a 5-foot window size. Initial distance is going to be 0.05 feet in this case, and a maximum distance of 2 feet. Basically, this is the maximum height something can be and still be considered on the ground. And it's important not to make that too small because you can cut off the tops of hills and so forth. And what I'm going to do now, I'm going to right click and I'm going to end the command, and I'm going to turn on the draw polyline command. And what I'm going to do is just draw a polygon around the machine, and I'm actually drawing on the photograph, which is probably looks a little bit strange. And I'm also going to go ahead and draw a polygon around this area as well. So this is obviously has some stuff that needs to be thinned out. And I'm picking a smaller area because this algorithm is going to run a lot faster if we constrain it to just work inside of the polygon. And that way it's not going to affect the rest of the surface, which really doesn't need any thinning. So now I'm going to go ahead and turn off my image overlay. I'm going to use the right mouse button. I'm going to select crossing. First I have to pick the cloud and initiate the object command for filter. Let's remembered our settings from last time. Now the trick is I'm going to right mouse click and I'm going to add a single polygon to the selection set. You can also press the control key down and click on it. And now I'm going to apply the Bareground filter. Runs pretty quickly, but I see that we still have some points in there. So what I'm going to do is I'm going to increase the window size to 10, which is the sampling size. So it's going to, instead of just sampling in a 5 foot by 5 foot grid, it's going to expand it out a little bit. And I think I'll still keep that at 2. There we go. It actually looks like it's got rid of everything that we wanted it to. Yep. So now that part's nice and clean. And now I'm going to simply come over here. I'm still in the command, and I'm going to right mouse and select with the crossing this other polygon. And I'm going to leave it at this particular setting for now. But we have some things that are a little bit bigger than 10 feet over here. So that ran nice and quick as well. Let's see, do we have any leftovers? That actually looks pretty good. I'm going to do one more that's a 20. So I'm going to increase the sample size because this is fairly sparse. Okay, and I'm going to press the right mouse button and end the command. I can see that we have 920,000 points. So I'm going to go ahead and create a surface, a TIN model from this, and I am going to use the slight simplification because a straight up Delaunay triangulation would produce about 2 million triangles, and that's really a pretty large number for most software packages to calculate volumes and to work with effectively. So what we're going to do is we're going to use our simplification optimizer, which basically combines a lot of faces where the elevation difference is extremely slight. So it's a very good optimization algorithm that Carlson has produced. And this is usually about the longest. Okay, and there we go. Now that that's finished, I'm going to go ahead and I'm going to turn off the point cloud visibility. I'm going to drag and drop a little bit better texture on there, and then I'm going to go down and take a look at these results, and it looks like it did a really nice job of cleaning up all these points that would have been hanging up in here. And the same is true for this, so the truck and everything appears to be gone. Now what I'm going to do, just to spot check even better, is I'm going to go ahead and reload that overlay. And again, I'm going to specify the projection, Michigan South, and I'm going to drape it to the surface this time. Now we can go down and see the real effects of this Bareground cleaning. So there's actually a dirt pile right along in here, so we did pick up some of that dirt. But we certainly don't have any machine parts hanging up here, so it did a really good job of cleaning that out. And we can go over here to the truck, and we can see that completely removed those points. Come over to the house and this debris pile and all, and we can see that it's removed all of those as well. And we come over to yet another vehicle, and storage facility, and it has also been removed. At this point, I don't need the polylines anymore, so I'm just going to go ahead and delete them. And there you go. Using polygons to constrain the Bareground algorithm, which can take a long time to run. And by a long time, I mean a few minutes. But if you constrain it to areas where you know that you want to work in, and you can use different settings. So I can draw a polygon here, and I can apply different settings that are more optimal for removing this machine than for removing cars, which are a lot smaller. So you would use different parameters for that. And by using the polygons, you could basically apply different parameters. And again, if you apply a filter and it takes out too many points or gives you a bad result, you can always hit Control Z even during the command, and it'll undo the last filter. And then you could tweak your settings, and then you can reapply. You could reapply the filter at that point until you're satisfied with the results. So there you go, advanced Bareground filtering on unclassified LAS data using Polygon boundaries.